Hello YouTube. In this video we're going to be discussing solving trigonometric equations, but specifically trig equations in which there are more than one trig function involved. So previously I've gone over videos on how to solve these when there's only one trig function involved, in which you just isolate the trig function, and of course we'd use inverse trig functions to undo them. But in this case you'll see that I've got a couple of examples listed up here. So let's go ahead and get started on this first one here. It says solve secant x minus 2 tangent x equal to 0 if x is somewhere between 0 and 360 degrees. So the first thing I want you to notice is, yes, we have two separate trig functions. So our main ambition here is going to be to make them the same trig function. So these two examples are unique in that we could rewrite these using some trig substitutions. So you might recognize that secant x, okay, so secant x is the same thing as 1 over cosine of x. And then we are hopefully also aware that tangent of x is the same thing as sine of x over cosine of x using our ratio identities. Okay, so we have this all equal to 0. And what I want everybody to notice is this. Essentially, that these both have denominators of cosine of x. And so a very effective way to take care of a situation like this is to go ahead and let's multiply everything by that denominator to eliminate it. So we're going to take the entire left-hand side of this equation times a cosine of x, and what that's effectively going to do is cancel out, when we distribute this, our cosine x's in the basement. And then on the right hand side here we have to take this times cosine of x as well, but that's convenient because cosine of x times 0 is just 0. So when we distribute this cosine of x here, you'll notice here that it cancels out with this first cosine of x, and we just get left with just 1 over the numerator. This will be 1 minus, now this cosine of x when distributed to the second term cancels out with that cosine of x, and we get left with just 2 and then its numerator, sine of x. And so from this point we can actually just go ahead and isolate our trig function as we're used to doing. So that would be, we could subtract 1 from both sides and be left with negative 2 sine of x, then sine of x equal to negative 1, since we subtracted that to the right side. And then we say, okay, so divide by negative 2, divide by negative 2. We end up with sine of x being equal to positive 1/2. And so now to solve this, we shall take the inverse sine, or the arc sine, of both sides of this equation. So we say sine inverse of this quantity on the left cancels out our sines. And so we say we must do the same thing to the right here. So sine inverse of 1/2. So we get x equals sine inverse of 1/2. So now recall that we wanted to get our answer somewhere between 0 and 360. So really what this is asking is, okay, so where in the world would you have a sine value that's equal to positive 1/2? Okay, so you might be aware that the only time you get a sine of 1/2 is if you have a reference angle of 30 degrees. So if we were to necessarily sketch out all angles that have reference angles of 30 degrees, so that'd be something like right here, 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 and here, we're primarily concerned with the sine where sine was positive. We got a sine value of a positive 1/2. So sine is positive, if we know our mnemonic here, all students take calculus. Sine is positive in the first and second quadrants. So if all of these reference angles here are 30 degrees, all of these, okay, and we're interested in the angles in standard position in the first and second quadrant, that'd be this angle here, 30 degrees, and also this angle here, which is 30 degrees shy of 180 degrees. So we get our solutions to be 30 degrees and 150 degrees. Okay, and this can be easily checked by plugging these back in. So I want to do one more quick example, well, not a quick example, but another example of the same type. You'll notice that we have cosine and secant here. So in order to remedy this, what we're going to do is we're going to do a trig substitution with our secant on the right here. So we end up with this: 2 cosine theta minus 1 is equal to 1 over cosine of theta. So now, noticing that we have a cosine of theta in the denominator here, we're going to multiply both sides through by cosine. So if we take the right side by cosine theta, that cosine theta and that cosine theta cancel out, we get 1. Now on the left we have cosine theta, and we need to distribute this. So we end up with 2 cosine squared theta minus cosine theta. So now, since we have a squared cosine in a cosine to the first, what we're going to do is we're going to use the strategy of factoring. So in order to solve by factoring, of course, we need to set this equal to 0, which means we'll go ahead and bring this 1 back over to the left. And what we end up with is then 2 cosine squared theta minus cosine of theta minus 1 equal to 0. So now, attempting to factor this here, in order to get our 2 cosine squared in front, we're going to have to put a 2 cosine theta and a cosine theta in the front of our two binomials here. And in order to produce a negative 1, we'll go ahead and we'll shoot for, how about plus 1 minus 1. So now we're not guaranteed on this. We actually have to check our outer and inner multiplication here. And you'll notice that if you do your outer multiplication here, you get 2 cosine times negative 1, which is negative 2 cosines. And then the inner, you get 1 times cosine, which is positive 1 cosine. But you'll see that these actually sum up to be the middle term here, which was negative 1 cosine theta. So this is good. So this is our factored form. So now since we have this factored, we're really saying we have a number a times a number b equal to 0 when you multiply them. And that is only ever the case if either of these factors is individually equal to 0. So the nice thing about factoring is now we can set each individual factor equal to 0. So that is 2 cosine theta plus 1 equals 0, or cosine theta minus 1 equals 0. So in this first instance, we'd subtract 1 from both sides and get 2 cosine theta equal to negative 1, and then divide by 2. So we say, okay, so cosine theta is negative a half. And therefore, theta is equal to cosine inverse of negative a half. So for our equation on the right here, we would add 1 to both sides, and we get cosine theta is a positive 1. And therefore, theta is equal to cosine inverse, after taking the cosine inverse of both sides, of 1. So now we need to solve for all the angles that would make these equations true. So as a matter of convenience, what we're going to do this time is simply this. We say, well, where would cosine be equal to negative a half? We can go look at the unit circle here. You'll notice that the only two values for which cosine is negative a half, or x value is negative a half, is 120 degrees and 240 degrees. So we have 120 degrees and 240 degrees. And then now to solve this equation right here, we say, well, where is cosine equal to 1? Well, where's our x value equal to 1? And that is at the angle 0. 0. Okay, 0 degrees. So now, I suppose we were supposed to do all of this in radians. We could also have said, okay, so 2 pi thirds and 4 pi thirds, as well as 0 radians for all these. So we say 2 pi thirds, 4 pi thirds, and 0. So that's a quick example, or a quick couple of examples on how to solve trig equations, or at least one way to do it. When you have more than one type of trig equation, you try to eliminate one and just isolate the remaining one.